Okay, hello everyone. Today our topic is about thermal physics part 2, okay? And here is our today's content. First, we are learning about liquids and vapors, and then the second part is specificity capacity. And you can find here, we no need to master the latent heat, no need to master this chapter because this is deleted by the latest chapter, latest syllabus, okay? And then we'll have a little bit conclusion for this, okay? So let's move into the first slide about evaporation. So you can find in this figure, many particles or molecules are arranged in the liquid, right? And you can find what is evaporation. That means so like very tiny balls that represent for the water molecules or like liquid molecules, right? They just escape from the surface, right? So now maybe we have to discuss how we can make an influence on the little balls to escape from the surface, right? So maybe for the first one, we can consider each ball are standing in a quay, right? Like here, they're just standing in a quay. So if you want to escape, maybe first you have to standing at the very front of the quay, right? So maybe we can say that for every little molecules, they have to at the front of the quay, or you can say that they are very close to the surface, right? So they can evaporate, right? Okay. And after that, maybe we can use another way to maybe discuss about this. So for the evaporation, we can set if you just want to evaporate, it must be the surface liquid to evaporate, okay? So it doesn't like boiling, it just occurs on the surface, okay? So we can say that evaporation occurs on the surface, okay? So here is the first properties for evaporation, okay? And maybe for the second part, we can find maybe you are in the queue, right? But some particles can maybe escape very easily because they have a very high speed, right? But maybe some of the particles will remains in the liquid, okay? So for the second property, we can say that only if you have a very high speed, then you can escape, okay? This is for the second property for evaporation, okay? There are two property here, and to remember that it's very important, okay? And maybe here we just discuss about how we can make a property or discuss the properties for evaporation. And maybe next we will discuss about what will influence on the evaporating speed, okay? So there are three ways to increase the evaporation speed. First, you can increase the temperature, right? Because we have already discussed about that if the particles can move faster on the surface, they can escape very easily, right? So maybe increase the temperature, we have said before that we can increase the average speed of the molecules, right? So once the average speed increases, we can say that the they maybe runs faster and they can escape easier, right? So by increasing temperature, we can increase the average speed for this. Okay. And the second method is to blow air across the surface. Okay. So maybe you have a question. So why we can using the blow air to increase the like escaping speed or like they can make the evaporation, the process quicker. Okay. So I'll give you an example. I remember when maybe 10 years ago, I go to Malaysia for traveling. And at that time, maybe there's no washing machine and maybe that is for a very cheap hotel, okay? And there's no washing machine and there's no dryer machine in the uh, hotel, okay? So at that time, it's very like hard for me after every day's traveling. So I used up all my clean clothes, okay? And at that time, I kind of found the laundry because I'm not very familiar with comfort. Okay. So at that time, I just using the hair dryer to blow up all my clothes. Okay. And I make maybe wash them in the sink and then use a hair dryer to clean them. Okay. And you can find if you're just hanging on your in your hotel or hanging in your room, maybe the wind is less, right? And it cannot dry very quickly. But if you're using the hair, because the hair dryer, it can make it very quickly to dry up, right? So you can find because I'm using the way of blowing the air, right, across the surface of the clothes, so my clothes can easily dry, right? So I can say that using the blow air across the surface, maybe you can think regard it as like you're using a vein here. And for the liquid, that they're like a flower or like a pollen flowers, it can just run up with the wind, okay? So they can escape more easier, okay? And for the third reason is that, or for a third way or method is that to increase the surface area. Like if you just put a drop of water in the surface, or like put a tank, or like maybe a beaker of water is in the surface or in the environment, we can say that because the volume is increases, right, and the surface increases, then we can evaporate more at the same time, right? Like you're using a beaker or using a bottle on the outer side. And maybe if you want to compare with a lake, maybe the lake can evaporate more because their surface is big, their quantity of the liquid inside of this is bigger. Okay, so we can like evaporate more. Okay, these three ways can help us to evaporate or increasing the evaporating speed. Okay, so please take a note for the three very important properties right here. Okay. And for the next part, we will discuss about the boiling. And we can say that boiling here, you can see in this figure, there are bubbles from the bottom to the top, right? And bubbles are fulfilled in the beaker, right? So first one, we can say that boiling maybe is like more severe than in the evaporating process, right? So we can say that for the process, the boiling maybe is more quicker than evaporating, right? This is for the first property, the process difference, right? And also you can find, we have discussed before that evaporation only occurs at the surface, right? But here you can find bubbles are fulfilled in the liquid, right? So we can say that the evaporation or the boiling just occurs in the total body for the liquid, right? So for boiling, we can say that it maybe occurs in the total body in liquid, right? So here is for boiling. Please remind that, okay? And we can say that if you want to like increase the speed of boiling, maybe you can using different kind of Bunsen burner. Maybe you increase your power apparatus, and maybe let the heat loss like decreases. We can increase the speed. Okay, but there are the two properties. And remind that boiling maybe for every liquid is at its boiling point, right? So here the temperature doesn't change, but it still needs heat to remain at the boiling point, right? So you can set it still absorbing heat, okay? This is for boiling, okay? So to please remind the third property right here, okay? And also we can say that in evaporation, it also needs to like absorb heat, okay? So this is for evaporation and for like the boiling, okay? But here you have to remind that for liquid evaporation, although it absorbs heat, but its temperature maybe can be lower than before. So maybe you have a question. So why why is this? Because we absorb heat, like maybe our temperature will increase, right? But remember that because you absorb heat, that makes the surface particles to like just escape, right? So the escaping speed or the influence by escaping the like higher speed particles are bigger than the total liquid to maybe absorb heat. Okay, let me say that the heat taken away by the surface particles is bigger than we are absorbing the heat. Okay, so here's for evaporation that they make a difference that they're although they're absorbing heat at every time, but the temperature decreases. Okay, because the surface particles just takes away the heat more than they're absorbing. Okay, so there's a difference. So for the liquid, we can say in the evaporation, the temperature decreases, but when it's boiling, the temperature remains at the same boiling point. Okay, so here's the difference. Please remember this and take a note of this, please. Okay. And another very classical like transfer is about condensation. And this is just from the like vapor or like from gases transfers into the liquid, okay? And here's an example, like we are boiling water in a kettle and the kettle releases the water vapor, right? But from mine here you can find there are some like white gases, or like there are like some maybe it seems like to be a gases, but to remind here that they are the water bead. They are very, very tiny water beads, so that they are the white color, okay? So for the water vapors, they have no colors, but here they are water bead because they maybe contain some like maybe here is a dust in the air, and maybe here are some like other substance in the air, so maybe it can contains for this, and it forms the white color. Okay. So here you can find once the water vapor comes out from the mouth of the kettle and it face the cold air, and then it forms the water bead, or we can say it forms the liquid. Okay. So based on this, we can say that condensation just leads to release heat, right? Maybe from the water vapor, just release heat and to form water bead, okay? So we can say that's release heat. And this is from the gases to the liquid, okay? So here, please remind that this is the condensation, okay? And after that, I have to draw about a graph of like different, like say changing. We have the solid and liquid and for the gases. Okay. And for here, we can say from solid to liquid is we call this process melting, right? This is for melting. And for melting, we have to absorb heat and the temperature remains at the melting point, right? And from liquid to gases, we can say there are two processes. One is called evaporation and another is called the boiling, right? So boiling is like more heavier than the evaporation and the speed is maybe like faster than evaporation, right? Evaporation absorb heat, right? But the temperature decreases, right? Boiling also absorb heat, but the temperature remains, right? So this is for here is remains. Maybe I'm using a right arrow to represent for remains, okay? And we can set from the gases to liquid is condensation, right? And maybe for liquid to solid, we can say that it's freezing, okay? Like this way. Okay, so maybe here's a very famous movie called Frozen, right? Using the word freezing to represent for liquid to solid. Okay, and from the left to the right, we can say this process absorb heat, and from the right to the left, we can say this process just release heat. And in IGCSE, maybe the past papers shows that the melting process, evaporation, and boiling process, maybe it's more appeared in the IGCSE test. Okay, so I also want to maybe introduce you a new graph for the temperature and time taken graph. So this means that maybe from the solid to the gases, here is a temperature and time. Maybe you're using a heater to heat a solid, okay? And here is a temperature and time graph like this way. Okay, so this is for temperature time graph. You can find when the time increases, the temperature first increases and then remains, and then increases and then remains. Maybe here at the last, it still increases like this way. So let's discuss about the different process or different state in different lines, okay? For in the first section, we can say here is a solid heated, right? So we can say there solid is heated, so the temperature can increases with time, right? And then for the next section, you can find here the temperature remains, right? And we can find maybe here the solid is transferred to the liquid, right? So here it's just melting process, right? So here temperature is at the melting point, right? And then when the uh like the liquid is melting, sorry, the liquid is like adding the new heat into this, and because the substance is increasing heat. So here maybe using a new color. Here is just solid, right? Here is like a solid and liquid mixture, right? And after the point, after the terminal point, we can set here is all the liquid, right? In this section, right? And after that, we can find once it reach this point, it comes to the like boiling point, right? So here is a liquid and gases mixture, right? And then it totally forms into the gases. And then the last part is gases heating, right? And here is for the melting. Oh, sorry. Here's for the boiling. okay, as remains at boiling point, okay? Therefore, the different state of the solid, liquid, and gases. Please remember this graph. It's very important, and it shows up in IGCSE past papers for like maybe for 5 years. It shows up for like 4 times or 3 times. Okay, it's very frequently tested in our past papers. Okay, so this figure is also very important to remind here to know which section means which steps. They're very important. Okay. So maybe you can find this problem. Can you tell me the answer, please? Just take several minutes to think about this, please. Okay, so I guess you have the answer, right? So for A, you can find it said boiling requires a supply of thermal energy, but evaporation does not, right? But please remember that boiling requires energy, right? That is correct. So the temperature doesn't change because it's at boiling point, right? And for evaporation, we can find that here it also needs energy, right? It needs energy absorbed in the system, but the temperature now decreases, right? So evaporation also needs temperature, also needs energy. Okay, so A is not correct, right? And for B, evaporation takes place at the surface of a liquid, but boiling takes place throughout the liquid. That is correct, right? Because we have said before, evaporation only has the surface particles to run away from the surface, but the boiling has a total, like boiling in the total liquid, okay? And for C, we can say that the temperature doesn't change because the boiling is at boiling point, right? And for D, when water evaporates, its temperature increases. Okay, that is not correct because the temperature now it is decreases, right? So here is for our total part of liquids and vapors. I hope you can understand them all and try to take the notes of this. This is very important in the P2 past papers. Okay. So maybe here's today's our total lesson and see you next time. Bye.